Let's take a look at a basic if statement. It starts with a keyword if, and inside the parentheses is something that will evaluate to either true or false. So on line 21, if the total of N1 plus N2 is at least as big as 50, then line 22 will execute. Otherwise, line 22 won't execute. I'm also going to print something out just to indicate the code that will execute after the if statement. In all of my examples, that's going to be the case when you see this code down here. When I run the program and enter 30 and 40, line 22 does execute because the conditional question on line 21 was true. That is, 30 plus 40 is greater than or equal to 50. Let's run it again. This time I entered 20 and 30, and since 20 plus 30 is at least as big as 50, line 22 executes again. But what if the condition on line 21 is not true? Let's see. This time I'll enter 25 and 24, and their total is 49. Notice what happened. Because 49 is not at least as big as 50, the condition is false, and line 22 gets skipped. And again, lines 24 and 25 did execute because they're not part of the condition on line 21. They're going to happen no matter what. This drawing will give you a visual picture of how this if statement works. The programs you've written up to now are represented by the yellow line that has arrows on it. The arrows indicate that your program goes following one step after the other, but when you get to an if statement, and that's indicated by the blue curved line here, your program can take a detour. It's sort of like getting off of the interstate, but you only take that detour if the condition in the parentheses is true. Otherwise, you just keep on going following the yellow line. When the condition is true, you take the detour indicated by the blue line, but you come back to the part of your program that follows the if statement. So, to repeat, lines 24 and 25 represent that part of our program that comes after the if statement. I said earlier that something inside the parentheses had to evaluate to be true. So let's take a look at what that means to be true, at least in terms of if statements. When we make comparisons using the relational operators, like in the previous example, we always get either a true result or a false result. That makes sense. But as it turns out, expressions like N1 plus N2 greater than or equal to 50 actually have a value, a number value. And that's kind of strange. Here's the rule. If something evaluates to 0, it's considered false. If something evaluates to anything that's not 0, it's considered true. Let's look at this strange example. On line 21, I've got just a 2 inside the parentheses. 2 evaluates to 2, which means it's considered true. That means my if statement on line 21 is going to be true, and line 22 will print out that the total was at least 50 no matter what I enter on line 19. So when I enter 8 and 5, the output says the total was at least 50. But the reason why was because of that 2 inside the parentheses. In my next example, I put a negative 300 in the parentheses. Not surprisingly, negative 300 evaluates to negative 300, which is considered true because it's not 0. Watch what happens. I enter 2 and 3 for my integers, and once again, I'm told that the total was at least 50. Now that's obviously not true, but because of the negative 300 on line 21, the if statement says it's true. Let me put a 0 in the parentheses on line 21. 0 evaluates to 0, which is considered false. So now no matter what I enter on line 19, the if statement will be false, and the output just gets skipped. Take a look. I enter 200 and I enter 1,000, and I know that the total of those numbers is way at least 50. But you can see in the output that line 22 didn't execute because the if statement was considered false. I can put a variable inside the parentheses too. Here I'm putting a variable N1. That means the truth of my if statement on line 21 will depend on what the user types in for variable N1. The first time, I enter 6 and 10, and because 6 evaluates to 6, it's considered true and line 22 executes. The next time, I enter 0 for N1 and then 1,000 for N2, and those add up to be at least 50, but because N1 was 0, the if statement says, nope, that's false, so line 22 gets skipped. Just to show you that expressions using relational operators have numeric values, look on line 21 in this example. It's going to print out the value of the expression N1 plus N2 is greater than or equal to 50. Now that's a comparison. Take a look. When I enter 40 and 30, and their total is at least as big as 50, the value of that expression is 1. That's true. Running it again, this time I entered 15 and 3, and the value of my expression is 0, which is false. Here's a warning. Watch out if you're going to compare floating point values to see if they're equal. It works fine for ints, but not always for floating point values. Look at my example. On line 20, I'm just going to check to see if N1 is equal to 3.597. I run my program and I enter 3.597 for N1. Now that seems simple enough. So on line 20, N1 contains 3.597. That's equal to 3.597, so line 21 should have executed, but it didn't. When this happens to you, remember my warning. Watch out when you compare floating point values to see if they're equal. To show you what's going on, I'm going to add a line of code on line 23. I want to print out what N1 actually contains, and then we'll run the program again. Even though I typed in 3.597, what got stored in N1 is this number. Here's why. Numbers are stored inside of a computer based on powers of 2. That means most floating point numbers can't be stored exactly. Take a look in this case. That long number out here is close to 3.597, but it's not exactly 3.597. So the if statement says, nope, they're not the same, so it's false, and I'm not going to print out the output. What can you do to fix this? The answer is you, the programmer, have to decide how close do two floating point numbers have to be for me to consider that they're equal. Look at this example. On line 20, I'm subtracting 3.597 from whatever the user entered for N1, and then I'm going to take the absolute value of that difference. If the absolute value of the difference is within 1/1000th, then I'm going to call them equal. For this little program, that's close enough. Here's the result. Since N1 contains a value that is within 1/1000th of 3.597, my program says, hey, they're close enough. Here's a drawing of what line 20 really means. It's showing part of a number line with 0 and the value 3.597 shown on it. What the if statement is checking for is to see if N1 has a value that is within 1/1000th on either side of 3.597. If it's in that range indicated by the green lines, then we're going to say that's close enough. Again, it's up to the programmer or the specifications to determine what is close enough. Up to now, my examples have consisted of just one line of code that executes if the if statement is true. What if I wanted more than one line of code to execute? The answer is I use curly braces to indicate a block of code. On lines 21 and 27, I have curly braces that contain 5 lines of code. So if the if statement is true, all 5 lines get executed. If the if statement is false, none of those 5 get executed. Let's test it. 15.94 makes the if statement true because it's less than or equal to 23.6. So you see all 5 lines of code execute. Another example, I'm going to enter 24, which is not less than or equal to 23.6, so the if statement is false. And all of those statements between lines 22 and 26 get skipped. So far, with a plain if statement, either code happens or it doesn't, depending on whether the if statement was true or false. What if I want alternate code to execute when the if statement is false? For that, I need an else. In my example here, I'm getting the name of a city from the user, and on line 20, I'm checking to see if they entered Fort Worth. If they did, line 21 executes. If they didn't, the alternative line 23 executes. So this is an either-or situation. Here's the result. Notice line 21 executed as it should have, and notice line 23 did not execute. That's because line 23 was plan B. When I run it again and enter Austin, the if statement is false, so line 23 executes this time, but line 21 does not. Remember, it's an either-or situation. One or the other will execute, but never both of them. I can use code blocks with this if-else form also. In this example, I'm getting 2 numbers from the user, and then I'm going to have them enter a math operation. Since I'm getting string input on line 23 that comes after number input on line 19, I've got to use the ignore on line 20. Both the if and the else have their own code blocks here. When I run the program and enter 15 and 74, and then ask for an add operation, the first code block executes and the second one doesn't. When I run it again and ask for a multiply operation, since the if statement is false, the code block for the else executes. Watch out for the problem that I'm illustrating here. I left off the curly braces to indicate a code block for my if, and the compiler gives me a red squiggly indicating something's wrong. If I put the cursor over the red squiggly, the error says, "Hey, we expected a statement." Now that really doesn't tell you the problem. When I hit F5 to run it, I get a message box telling me I did something wrong. When you get one of these, always click No, then start trying to find out where the error is. Visual Studio is telling me I've got an else with no matching if. That almost always means you forgot the curly braces to indicate a code block with your if. Most programming languages are pretty modular, which means you can put things inside of other things. In this example, I'm putting if statements and elses inside of other if statements and elses. Sometimes the logic of a program requires that you do this. This is called using nested ifs, and it's sort of like those little nesting dolls where one fits inside the other. Look at how this works in my example. I've got my first if statement on line 20, and I've got a code block for it, and then I've got an else for it that begins on line 32. But inside each of those, I have other if statements and else statements. So the logic of nested ifs can get pretty complex. I'm going to run this program several times without comment from me. Each time, look at the input from the user and trace the logic of the program to make sure you see why the output is the way it is. It'll probably help to pause the video to do that. Ready? Here we go. Here's another way of looking at the logic of my example. I put the code in there too, so you can match them up. Sometimes it helps to think of these nested ifs as pathways, and you ask yourself, how would I get to this spot on the path? For instance, how would I get to print that n2 is equal to 100? This first if statement would have to be true, and then the second if statement would have to be false for me to get to this point on the path. Here's another example. How could I get to print n2 plus n3 is 5? The first if statement would have to be false, then the if statement inside here would have to be true for me to get there. This sort of thing is called the flow of logic of a program. It's all based on true-false, which is the most basic logic there is. It might help you to compare my diagram to the code. They should match. I've already pointed out one big error when using if statements, and that was leaving off the curly braces for a code block. Here's another one. On line 22, I'm going to check to see if n1 is equal to 100. If it is, I'm going to tell the user about it. Otherwise, I'll tell the user that it is not 100. I enter 100 for n1, and the program prints out the value of n1, and then it prints out that n1 is equal to 100. Okay, no great shock. I figure my program's working correctly, but just for grins, I'll run it again. So this time, I enter negative 65, and the program prints out that what I entered for n1 is negative 65, and then it tells me that's equal to 100. So far, my program is 1 for 2 when it comes to results. Do you see what I did wrong? Look at line 22. It has a green squiggly on it, which means Visual Studio is trying to tell me something that it thinks might be a mistake. I put my cursor over the green squiggly and look at this error message. It says, consider using 2 equals instead of 1 equal. And then it reminds me that a single equals usually means assignment, which means I want to store something someplace. Now, a lot of compilers won't warn you about this, so watch out. We're so used to using a single equal sign in math to mean is equal to. But in C++, 1 equal sign means assignment. So on line 22, what I really did was I assigned the value of 100 to my n1 variable. In other words, I changed it. And guess what? By assigning 100 to n1, n1 now has a non-zero value, which means it's true. That's why line 23 executed. Okay, so I fixed that problem, and I run my program as shown here. First time through, I enter 100, and it tells me the value of n1, and it says n1 is equal to 100. Everything's good, at least until I run it again. This time, I enter 74, and it tells me n1 is 74, and that it equals 100. Now here's a real common mistake that you got to watch out for. Look on line 22. Don't ever put a semicolon at the end of your if. It makes the if as though it weren't even there. So I could take a marker and just mark through line 22 because that's what happened to the logic of my program. And that's why line 23 executed when it shouldn't. It was no longer part of an if statement because of that semicolon. This next error is one that a lot of people make. The problem is on line 24, where I put a condition as part of my else. Remember, an else is just the alternative for an if statement that's false. That means an else doesn't have its own condition to check, ever. And this last example shows something that I've seen a lot of beginning programmers do. They put an else with just a semicolon. When I ask them why, they say, well, I really didn't want to do anything there. My friends, if that's the case, don't use an else. Remember, else's are optional when you need them. You don't need an else unless you want something to actually happen if the if is false. If you've heard some snoring during this video, I'd like to thank my bulldog Sunny for coming in to help me make this. Don't know what I'd do without her. So that's it for our quick look at if statements. I appreciate you watching this. I'll see you next time.